Hello and welcome to our latest construction technology webinar. My name is Andy Brown. I'm the editor of International Construction Magazine. This webinar is a joint venture between International Construction and Construction Europe magazine. Thank you to everybody who has registered for this. We have good numbers. I'm just looking now at the screen and I can see the attendees ticking up. So I'll just give it a minute to give everyone the chance to join us. So I can see the numbers ticking up. So thank you very much, everybody. So what I'd like to do as well is before we start, I would like to just take a moment to thank our sponsors, who are Smart Construction, Volvo Construction Equipment, and Inspire. I'd also just like to take a moment just to remind everyone that there is a question and answer box at the bottom. So if you would like to ask any of our panel questions specifically, or just have an open question, then please do type it in. And I will be checking on that throughout this webinar, and I will do my best to get to as many of those as I can. So now I'd just like to introduce, we have a very good panel for you today. We're very lucky. So first of all, I would like to introduce Alan Berger, former Senior Vice President Technology with Volvo CE and previously Chief Technology Officer at Case. Alan, thank you very much for your time.
Happy to be here.
Great, thank you. We also have John Downey, who's the Director of Sales EMEA at Topcon Positioning Group. Hello, John.
Afternoon, hi guys.
And finally, we have Gaurav Kikani, who is Vice President of Operations and Strategy at Built Robotics.
Thanks for having me.
No worries at all. So thank you very much for your time. It's a very interesting topic, automation in construction equipment. And to get us started, I'd like to ask you, Alan, in your time working in the sector of technology for a couple of major OEMs, if you could maybe just give us a view on how you saw automation develop over the years.
Yeah, absolutely. And to me, this is not a new topic at all. You know, I joined the industry in the mid-90s, and even at that time, we built I worked for Case Construction Equipment at that moment, and we built a technology roadmap, and that roadmap actually got us all the way to full autonomy. And you can guess, if we were building a plan in the 1990s, that it wasn't expecting to take until now to get to autonomous machines. So we actually had that on our roadmap that would have happened many years ago. We even launched an electronically controlled backhoe at that point in time, and it had some automated features. And some of the others in the industry, say Caterpillar's doing the basic R&D on what became their autonomous mining trucks. So things were happening back then. But the reality was the cost, and probably more importantly, the market, were really not ready. You see, customers were quite skeptical of this electronically controlled backhoe. Between then and now, I'd say most large OEMs, certainly the ones I worked for, had some level of autonomy research going on. So it's been a very, very long path. And along the way, you know, other things became more important. In the late 2000s, when oil prices spiked up, everyone got very focused on electrification, and the more visible pieces of the R&D and the bulk of the R&D budgets tend to move there, along with addressing all the emissions changes. So this really was, you can almost say, kind of a status quo until relatively recently, when you see these big advances in computing power and connectivity, and the resulting advances in AI, which has really accelerated. And at the same time, on the customer side, you see generations now that are much, much more comfortable with technology. So I see this is really the moment now where it starts to come together. And even more exciting for the industry is this convergence of the different technologies of electrification, autonomy, and connectivity.
Okay, thank you, Alan. John, just kind of picking up on that point that kind of Alan said, that obviously this isn't a new a new technology that we're talking about, but maybe one that we feel that has kind of picked up traction over the last couple of years. Could you just kind of give us a sense of kind of where Topcon are with kind of automation and kind of your main focuses?
We've been I've been selling machine control for over 20 years, but the adoption rate has been quite low, and we've sold a lot of individual aftermarket systems, and it showed an increase in productivity. But what we've seen now in the last couple of years is the demand for automation is growing exponentially across the construction industry. There was a report made by McKinsey Sciences that the construction industry as a manufacturing business, same as you'd manufacture cars or televisions or whatever, it's the least productive. If you look at the manufacturing industry since 1994 to now, it's doubled productivity. Agriculture is a manufacturing business. You get raw materials, you turn it into finished products. It's doubled its productivity since 1994. The construction industry since 1994 has gone down in productivity. So we've made better machines, more fuel efficient, more comfortable cabs. The machines are better built, they're nicer machines, but we're actually moving less material than we did 26 years ago. And there has to be a reason for that. And it's work practices have changed, they've become more strict. In the old days on the construction site, you'd work 10 or 12 hours a day and it was normal. You can't do that anymore. So as work practices have changed, they've become more strict. We've had to work to within more regulations. We're actually become less productive as a business. So the construction industry as a manufacturing business is less productive. And the only way to make it more productive is to automate it. It's like any business. Agriculture is way ahead of construction when it comes to automation. Farmers take this technology in their stride because they see it straight away in their pocket. The construction industry, I've built a road this way for 20 years. I stay building a road this way for 20 years. But now it's starting to change. We're starting to see the demand for this technology because it's a saving on material, the saving on time. There's a large shortage of qualified operators now. So the people who can operate the machines, they're getting older. There's not so many young people coming in to operate machines. So we're losing a skill base. So we need to automate the machines to make them more efficient. And they want less people on site. You do not want to have lots of people walking around active machines. So we're seeing a big demand now and a big uptake. And the manufacturers are also seeing this. So we're seeing a lot more technology now coming from the manufacturers. So the automation part is now coming from the factory, either in a basic form or a more advanced form. But they're starting to see this now as a demand, because everyone is in the same problem, whether anywhere in the world. Materials are not cheap, fuel is not cheap, and time is not free. So we need to save on all these, and the automation part will do that. So from Topcon side, we're seeing a demand for our technology because we can improve productivity, we can reduce the fuel usage, we can finish projects ahead of schedule. So demand on our side is growing. We expect to see probably in the next couple of years a 50% adoption rate on machines. It's still quite low, but it's growing at a rate now. If you put it like the hockey stick is on the curve now, it's starting to go straight up.
So what would it be now then, John, if you're expecting to see a 50%?
It depends on the machines. Motor graders they're not a widely sold machine, so the adaptation, and also the most complicated machine to operate because it's a finishing machine. So we've seen quite a high adaptation rate, sort of 50% plus on a motor grader. Dozers are now heading towards 50% because you can instantly see the benefit of productivity. If you can run a dozer in second gear instead of first gear, you've doubled your productivity straight away. So the technology can do that because a dozer as it goes faster, it bounces along because of the nature of the machine. The tracks have a shape to them, so the machine naturally starts to bounce. But we can actually take out that oscillation by using our technology. So we can actually smooth the blade out, so we can increase productivity. Instead of making 6 passes, we make 3 passes, saving of fuel. So the adaptation on dozers is very high. Excavators is low; it's less than 10%, but it is our biggest growth market we have. And it's the biggest untapped potential because it's the largest selling machine in the world. There's more excavators sold in the world than all the other machines put together.
Yes, absolutely. Okay, Gaurav, I wonder if you could just give us briefly a bit of background on kind of built robotics and kind of I'm sure you'd be interested to kind of touch on some of what John said there, especially with the excavators being a kind of a big untapped market.
Certainly, yeah. So Built Robotics, we're a technology startup based in Silicon Valley here in the United States. And our belief is, I think the construction ecosystem, just like Alan and John mentioned, it is very, we have the world's best manufacturing companies involved, OEMs. We have great technology companies, particularly, I think the hardware is very rugged and robust. But I think the critical element to taking the next big leap for construction is really going to be on the software side. And that's how, that's where the core technology behind automation really exists. And so we were founded about 5 years ago now, 4 or 5 years ago. We're based in California. And our focus is very much to develop an aftermarket upgrade system that allows for full autonomy. So we're talking about level 4 autonomy where there is no operator inside the cab of these machines, and the machine receives some commands for what it needs to perform that day. And with no supervision, the machine is able to complete that task in the day. And so we view this as kind of the natural next step in the progression of automation and construction technologies. And really, we think this is the paradigm shift. This is the big leap, probably the biggest thing since hydraulics as far as heavy equipment is concerned. And I think the benefits are multifold, just like John was mentioning. I think when people think about automation, they think about labor productivity and labor savings. And that's certainly true. And that's a big piece of it. But if you start to think about how equipment is used, and today, the way you use your heavy equipment is tied to how your labor works. So if your labor is working 8 to 10 hours a day, your equipment's working 8 to 10 hours a day. But when you start to disconnect those two, you can start to utilize your equipment far more efficiently and effectively, getting operations up to 24 hours a day, 7 days a week. And so when you start to do that, your return on your capital invested in your equipment starts to increase dramatically. You can do the same amount of work with 1/3 of the equipment, or you can do 3 times the work with the same amount of equipment. So I think that's really going to be a game changer as far as how projects are planned, how construction timelines are compressed. So we think that there's going to be a lot of opportunity there. And then I think it goes without saying, safety is another big thing here, where if you can take people out of harm's way, and if you can perform risky projects without putting an operator inside the cab, I think everyone wins. So we think that there are some really big tailwinds behind this shift in the industry, and I think it's only going to get more and more interesting as the years go by.
Okay, great. I mean, safety is a topic I'd like to pick up on in a moment, if I may. Before that, I just wonder if are there any what specific areas of construction we think are maybe most suited to automation, and whether we think, what might be the first sector to be kind of fully automated. I've sort of heard it before said that might be compaction. I wonder if anyone's got a view on that and would like to answer that.
On compaction is a difficult process. What we see, especially finishing the road, is critical. We're allowing not such a highly skilled operator to control the finished surface. With compaction, the way we work now with compaction is we use the compactors as sensors. They're basically sensors just recording data now. Every compactor will give you stiffness. Every compaction will give you temperature, and every compactor with GPS we can measure how many times it passed each point on the ground. So I can give you a centimeter by centimeter result for the project. To automate that would be a logical step, because all they do is go back and forth. When they reach the optimum compaction, they should stop. And you can decide that by how much vibration is used to improve the stiffness, and how many passes, and the temperature of the material. So that would be an easy start. But again, total self-driving compactors are still probably too scary for the asphalt business. It's quite a conservative business. They're still quite happy to go out and take individual samples on the ground.
Mm-hmm.
You build 20 kilometers and they're taking samples every so many meters, where modern systems can give you a centimeter by centimeter result. So it's still quite a conservative business, but it's changing a lot. We do a lot now with airports and so forth, where we use a system for resurfacing airports, and it's the whole workflow is completely automated nearly, from scanning to design to milling and to resurfacing. It's one big workflow now, and with the least amount of input.
I think that kind of leads into the kinds of environments where you're going to see automation first, where there's more controlled environments, bigger jobs. You know, the place that's been going on for a long time is in mining. I think it's sort of obvious there. I know mining companies are investing themselves in autonomy. Yet, kind of to the point about that you made earlier, John, about kind of adoption rate. I just saw a report said only 3% of mining equipment worldwide is autonomous right now, even though largely the capability is there.
Mm-hmm.
Yeah, I think the framework we use to think about it is basic repetitive tasks that can be performed sort of individually. You know, you want to start with the simpler operation, so equipment that works on its own versus having to interact with other equipment and people. That's always going to be good candidates for this kind of thing. And I think to Alan's point, you know, the larger infrastructure, large earth moving projects are the best suited for this. So mining is obviously a natural example. I'd say oil and gas and renewables projects are also showing to be good greenfield settings where you can have an excavator or, you know, a bulldozer working on its own in a relatively controlled manner. And I think those are probably the best first applications.
Okay, great. So we've got a couple of questions that have been coming in. So thank you for that, and please do send them in. So this one is from Stacey Smith, who asks, what type of cost increase is there between a traditional operated piece of equipment and a fully automated piece of equipment? And is there proof of ROI due to wages, insurance, and so on?
Certainly. Yeah, I can take a shot at that one. So from a cost standpoint, that's a big focus for us to make sure that this kit does not incrementally increase the cost of the equipment materially. And I would actually say that the cost of these kits is, you know, slightly above machine control, but not much more. And for that, you get the full automation and a significant ROI. So we see that you can start getting savings day one. And the way we've also been thinking about it is that rather than having to purchase a full kit up front, you can have what we call a robots as a service model, which is a little bit more of a recurring monthly model rather than having to put all the cost up front. So there are some models emerging which will kind of smooth out the costs, and you're realizing the returns on that from day one. And we think that the savings are significant, right? I mean, you're talking about significant labor savings. So, I mean, labor is about 30% of your overall cost. You're addressing that, but then all of the, as Stacey mentioned, the safety benefits, insurance, you're seeing fuel savings even because the equipment is being actuated in a more controlled manner. And you're realizing gains because you're operating the full 10-hour day. The robots don't take breaks, things like that. So we're seeing some very significant, you know, paradigm shift type of ROI on the technology.
Okay. Can I just quickly, there are some more good questions coming in, which I'll get to in a second. We touched on safety before. If we could just touch on that again, how would, I mean, I'm just curious. I mean, I don't know the answer to this. Is it, who is responsible if there is, you know, if something goes wrong with, you know, an automated excavator or something like that? Is that the responsibility of the OEM, or would it be, you know, the tech company that put it in? I mean, how does that work in terms of the safety aspect?
We're into a whole new realm. What we have at the moment in machine control is the operator is still in the cab. So for the typical system we sell, even an automatic system, the operator can take over the controls, and he is still in charge. When you have autonomous machines, you're in a different realm. Even to the you have to be able to recognize all the hazards. So you need to see whether it's a person or a car or whatever's entering the work area. Then is the safety, is it active safety or passive safety? While the operator's in the cab, passive safety is basically just a flashing light that someone is entering your work area. Active safety, you should stop the machine. then you're in a different realm again. This is untried territory. In the normal construction world, we don't have driverless machines at the moment. We have automatic machines, but with the operator still inside the cab. So all we're doing is we're improving the operator. We're making him more accurate, we're making him quicker, but we still have the operator. And for the moment, that's all we have in today's business. Now, the future, that's a different thing. But yeah, it is a complicated world, especially on a construction site where there are people, there are other machines, there are trucks coming and going. It's a busy environment. So you're going to have all your boxes ticked for this level of safety.
Yeah. I think it is an unsolved question at this point. You see this in the automotive world. When a fully autonomous car crashes, is it the car company's fault or not? Certainly, OEM perspective is the OEMs are usually the bigger players in this chain, and OEMs are always going to be extremely sensitive to making sure safety systems are fully in place and these things are as safe as possible.
Okay, and then there's another question which I think could be relevant potentially for all three of you, but I'll just not read it all out because it's quite long, but thank you very much. It's a very good question. It's from Ode Al-Hashami. I'm sorry, the pronunciation of your name is probably terrible, but he's basically asking if you can share an example of a qualified impact that automation has had on a specific project. So that could be in terms of cost reduction, quality, safety. So I just wonder if you have any, because obviously this is a very interesting topic, but it'd be great to kind of get, kind of really dig in and get some specific examples of different projects.
Well, a typical example, if you're building a road, the most expensive material you put on the road is asphalt. It's very expensive. And everything has to work in a window of tolerance. If you can increase the cheap materials and decrease the expensive materials, so with machine control, the base materials, the stone and so forth, you can break that as high as possible within the tolerances. It's cheaper. You make that really, really perfect, perfectly smooth, perfectly on grade. Then when you start putting asphalt down, you put the minimum thickness of asphalt needed. I've done it on projects where we saved over $1 million in asphalt, because we were able to work in the lower window, because you're not fixing any unevenness with an expensive material.
Mm-hmm.
Simple thing like that. And that's very easy to do. Saving in engineering costs, you go to a normal construction site, every 10 meters, they put pins or pieces of wood in the ground, and they measure from that. And that is their reference upon the project. With machine control and automation, you don't need these references. They're a manual check. So if you're doing 20 kilometers, every 10 meters, you put these references in the ground. You pay an engineer to do that. That costs so much per hour per engineer to put all this in the ground. Instant saving. So the savings in materials, the savings in time is really expensive. If you have 500 people on a construction site and you can finish a month early, that's 500 salaries. That's a normal. This is where we're looking, and it's even when we in regions where labor is cheap, diesel is not free, material is not free. And time is still costly, so you can still save money. And a typical construction site would use $1 million of fuel every 2 or 3 weeks, because these machines are very, very thirsty. Even the latest machines, they still use a lot of fuel per hour. So if you can reduce that bill even we're looking at savings of 30%. That's a massive saving on a construction site, because it literally is a constant supply of diesel going to these sites. So again, they're the sort of normal savings we look at, especially in asphalt. When you're building a road, it's a huge amount of material that goes into building a road. If you can just reduce that even by 5 or 6 millimeters across 20 kilometers, that's a lot of material, a lot of expensive material. So that's where we see the benefits to the customers. With the technologies that we have today, and as technology improves, we can improve on that, because now the machines are all surveyors. Every machine will now record what it does. So now you can then actually map as you go. So as you're building the road, you're also mapping the road. So you're saving on the cost afterwards. Huge savings.
Sorry, John, I was just going to ask, Gaurav, is that the number that you guys will be saying? So John mentioned the 30% there. Does that kind of tally with what you guys are seeing?
Yeah, it does, and we think that there's room for more as the technology matures, as you get more autonomous equipment on job sites working together. You'll continue to see sort of returns to scale there. And a few more examples of where we've seen costs come out. I think I couldn't agree more with a lot of what John said. A couple of other examples are we've frequently seen grade checkers on site, kind of with an equipment operator who's running the equipment, and the equipment is all self-surveying, and so you can gain some efficiency there. Rework is another really big piece of this, right? Is mistakes are costly, and mistakes take both time and additional work. Computers will do basically what you tell them to do, and so as long as your inputs are correct, every time you'll see kind of the right output. And then we can sort of start to broaden this more, where I think construction, it's still transitioning into the digital age. So all of the telematics, all of the data that we should be getting on a machine level of exact production per day, how much material was moved, how well are these machines working, those are all things we get for free with automation. And then I think the as-built we get as well. So digital files to know exactly, this is what the plan said, but this is what was actually produced. And this is where the trench went in or the foundation went in. We can do that reconciliation on the back end, which ultimately ends up, paying off over the lifetime of the project. So we see kind of lots of secondary benefits of automation beyond just the labor and equipment savings.
Okay, great. And then there's another question that has come in on the Q&A. We've got quite a few now, so thank you very much. This one is for Alan, and it says, do you see any barriers for OEMs to put more autonomous systems into their vehicles, and will this affect the aftermarket business?
So I think there's no fundamental barriers for growing autonomy. In fact, you could argue, and I think maybe John mentioned it, machines today, despite the best effort of the various OEMs, they're converging in performance. The fuel efficiency is getting closer and closer together. The productivity is getting closer and closer together. So the ability for an OEM to differentiate itself based on the mechanical product is getting harder and harder and more expensive. So the increments get smaller, it costs more to generate those. So I think actually driving towards autonomy, which is obviously a new space, open space to a large degree, and therefore more opportunity to differentiate, I think actually, if you think strategically for an OEM, is a very interesting place to move into.
Mm-hmm. Okay, great. And I've got a question, which is, again, is an open question to all of you, really. We touched on the skill shortage and kind of how automation can help with that. I wonder, though, as well, do we all in the industry need to do a better job at kind of reassuring operators that this technology isn't there to necessarily take their job away from them? It's kind of there to kind of help them to be more efficient and less fatigued, and kind of whether, maybe this would maybe go forward a bit quicker if maybe we could get some more operators on board. I wonder what if anyone would like to take that one.
I think what we need to do, there is a skill shortage in the construction industry of good operators. Like I said, what we're seeing now, the average age of an operator on site is 45 to 65. There's no young people coming in to operate machines because they can earn a similar salary working in an office or a factory, not get cold or dirty, and not have to travel. They travel to the same place every day. If you're in the construction business, every 6 months you move into a different site. So it's not as appealing. So we're not getting as many young people in. What we need to do is upskill the operators. We need to bring in a higher level of operator. And with the technology, you can, because now the operator is in charge of a project. He gets his drawing sent to him electronically to his cab. He has to go and dig his trench. He digs his trench. He then lays the pipe. He then can actually survey the pipe with the machine, so he can actually do the survey, and that data is sent back to the office. He is now the data manager for that part of the project. We're now looking at a higher level of person. You don't need to put an engineer on site or a surveyor on site to check his work. He will do this. You can now pay him more money. You get a better quality of person. And the automation is there to help him do this quickly and do it accurately, but he now becomes the data manager. It becomes the material manager. If you need to fill this area with material, he needs to know I need to take from this area to this area because this is my drawing.
But is that an issue with, in terms of, if there's someone that's, without wanting to be too stereotypical in terms of age, if you have a younger operator who's grown up with technology, then they might, straight away buy into that. But if you have someone that's been doing this job for 20 years or 25 years in a particular way, I guess that's more of a step change to say, well, no, actually, this is how we're going to do it now.
Yeah, but it also makes their life much less stressful. They're now concentrating on the material rather than on the grade. The grade is handled by the machine and the automated part of the system. They're keeping an eye on the material, that I have enough material in front of the blade, or I need to take material from here to here. They're managing more of the project, and they're not so focused on the automation, the actual machine part of it, the actual accuracy part, because the system will do that. We've worked with older and younger operators, but the fact is we have a shortage of good operators.
Mm-hmm.
Yeah, and Andy, I think to your point, there is still an importance to having experienced operators in the mix, because having an understanding of the machines, understanding of how good construction practices work is still going to be really important. And I think it's short-sighted to think that we're going to automate everything in the next few years. So there's still going to be tasks that require human finesse and judgment, where you might need an operator to just jump back into the cab of even the autonomous machine and take over manually, knock out the tricky parts, and then set it back into autonomous mode. So we think that there's going to be a lot of benefit to involving the experienced operators. And I think one of the other interesting things we're seeing emerge here is, I think when we talk about automation, we think that labor is going to fight automation and technology. And we've been trying to tackle that head on in the US, and we announced a partnership with the Union of Operating Engineers. They operate in the US and Canada. And basically, we've entered a partnership to train their members on this new technology, because I think to that point, it's very important to bring the experienced operators along, because their input and their expertise is going to be really important to successful deployment of new technologies in construction.
And maybe just one other dimension to this, given the shortage of really good operators, and I differentiate the ones that are great, and there are a lot of them out there that can do amazing things with the machines, but they're a small percentage of the population. As the need to expand your potential workforce, automation actually gives you the opportunity, particularly as operator assist functions as they build up, to make a average operator a really, really good operator, and a really good operator able to be a really good operator all day, and not just for the first few hours when they're fresh. So I think it actually helps level set the differences across people throughout the day.
Mm-hmm. Okay, so we've done really well, because we've kind of got half an hour in and we haven't mentioned COVID yet, which must be a record. I just kind of want to ask, kind of again, this is an open question, kind of whether we think that perhaps COVID-19 might be, you call it a force accelerator for certain types of new technology, and might that actually be a force accelerator for automation or semi-automation?
What we've seen in the past, I've been in Topcon a long time. In difficult times, people look for methods of doing things more efficiently, saving money, being more productive, and COVID is also part of that. The world is in a sort of a recession a little bit. The construction industry is at a point where now we cannot have lots of people walking around together on site.
Yeah.
So the automation, it negates the fact you need people around machines. We don't want people near live machines. It's just not a safe place anymore. So yeah, so we can reduce the number of people on site by having more automation. With the automation and the ability to have all the data in the cab with the operator, there's no need for him to speak to engineers or surveyors on site. The communication can be through the machine. All the machines talk to each other. You can, with all the technology now, every single machine is on the internet. So literally they can live message. There is no face-to-face communication needed with this technology. Yeah, COVID is going to be a strange world for a while. We don't want large groups of people working on construction sites. You cannot have them all together. But whether we will sell tons of automation because of COVID, I doubt it. But it may open the door to people thinking about this technology more and how we can make use of it in this strange world we live in now.
Yeah, I think it's an interesting catalyst in that we've had the first wave of adopters, a lot of contractors who were progressive, maybe younger, new leadership, and they were sort of the early adopters for this. But what we're seeing now is maybe a second wave of folks who might have been more on the fence about adopting new technologies, because let's face it, construction is a very operational intensive industry. You know, if you don't want to try new methods because that means you're losing money because things take time to work out the kinks and getting them to work smoothly on a job site. So, but I think COVID certainly is acting like a catalyst, forcing people to rethink how they do things, where could they find a competitive edge, and how can they keep their people most safe. And so we are starting to see sort of more interest coming from people who previously might have been a little bit more ambivalent about automation.
If you take the perspective of getting these solutions to the market, I think the COVID effect actually could be good news for guys like John and Gaurav, where my view is that the OEMs, given that they are also struggling a little bit right now, need to focus their development spending, and they're more likely, you know, my personal view, having come from but not working for one right now, more likely to focus actually on connectivity and on electrification, where the paybacks are actually faster and more obvious to them. And I think more likely to kind of slow down their automation work and leave it to the technology players and startups.
Okay, great. So we've got lots more questions coming in. One of them is for you, Gaurav, which is, how is Built dealing with a constantly changing terrain?
Yeah, it's a great question. I'd say 5 years ago, that would have been very, very difficult for us to do. But we've made some really big leaps in the underlying technology, the computing power that we have these days, in order to actually constantly be surveying the terrain and understanding what's around it and updating your models and your path planning based on that. So we use pretty sophisticated technology, both in terms of LiDAR and perception to understand what you're seeing around you, but also kind of monitoring the orientation of a machine at all times in order to understand how the terrain is changing around you. And this is occurring, you know, multiple times a second. So you're getting extremely fast feedback off these machines in order to adjust your actuation of the machine. So just like a human is using their senses and, you know, hearing the engine and feeling the tracks, we're doing the same thing with our sensors that help the computer make decisions just like a human would.
Okay, great, thank you. And we have another one that's come in that maybe you could have first go at, John, which is what is being done to make sure that different brands of machines are talking to / understanding each other?
All the brands of machines will take common file formats in, so from RIB in Germany or from AutoCAD or whatever. So we take a common file format, but actually speaking to each other at the moment, they don't. There's all the manufacturers are still protecting their unique IP. So we have cleverness, our competitors have cleverness inside the machines. When we try, as publicly limited companies, we need to protect our IP, but there is no construction site in the world where it has all one brand of excavator or all one brand of machine control system now. We're starting to see people choosing different brands all the time, and they want them to talk to each other. So as manufacturers, we are speaking to each other about the possibility of how we have limited connectivity. It's early stages. It's difficult to get 3 competitors really to speak to each other and actually start to open up certain levels of technology to each other.
Yeah.
So yeah, it is tricky, but this has been driven by some of the big global customers who would have multiple brands and they want them all to speak to each other in a similar language of some sort. Telematics was in the same position. Every manufacturer had its own telematics platform, and if you had 3 different brands of machine on the site. In the old days, you would have had 3 different types of telematic system, but now there's a commonality between them. So they share certain bits of data between each other.
Mhm.
So that's a possibility. At the moment, no. We will take common file formats, but as sending data back and forth to each other, no, not at the moment.
Okay. I've got a question for you, Gaurav, which I was just interested in how, so at the moment, if you were going to be working on a site, would you, and say you had, I don't know, 2 or 3 machines that were being used autonomously, would you have one, not operator, but you'd have kind of one person there on the site to oversee? Is that correct? And also, how do you see that kind of going forward in a few years' time? Is there a plan to be one operator for 5 machines or 7 machines, or how do you think that might go?
No, I think that's exactly right. So today we do want someone on the site somewhere to sort of be the supervisor, what we call robotic equipment operator. And so their responsibility would be show up in the morning, you have to fuel and grease your machine just like you normally would. And then you fire up the software. So it's on a tablet or a computer, and you basically tell the machine what you want it to do that day. And so once you've input that, you press the go button and the machine goes to work. And then that REO, that robotic equipment operator, can go elsewhere on site, perform other duties, or they can, run other robotic equipment as well. And so we see the world turning into, you have one person managing, 5 to 10 machines on a site in a given day. And over time, as we build more confidence in the safety systems, as we build more confidence in the machines themselves, that person could migrate offsite. We don't think that's going to happen in the next 3 or 4 years for sure, but over time, you could have a remote operations center that's central somewhere, managing your machines across all different job sites over time. So we certainly think that is where the future is headed. It's going to take a little bit of time to get there.
Okay. And just a quick question for you, Alan. I'm just sort of curious, in your kind of time at the 2 major OEMs where you were, did you kind of see a kind of a real change in terms of some of the people that you were trying to employ? I'm thinking, from kind of 15 or 20 years ago compared to kind of when you left. Did you see that real shift in terms of the construction industry now looking for more kind of tech-minded people?
Yeah, it's actually, I think, one of the biggest challenges for the industry, where, of course, the roots are in mechanical skills and hydraulics, combustion technology, things like that. The real need, the value add now is really in the electronics. Like I said a little bit ago, the mechanical parts of the systems are converging, and even to the extent that you can make improvements there, it's typically electronically controlled. So the real need now is for bringing in people with electronics capabilities, software, AI, data science capabilities, but then marrying it with the traditional parts of the organization, because all that deep product knowledge, you could say, is a significant part of the value that the OEMs sit on today. And it does you not so much good. I won't say no good, but not so much good to have a great electronics team over here and then the rest of the organization kind of sitting over here doing what it always used to do. So it's not just about bringing in the right skills, but it's about integrating those skills and getting the whole organization to understand new technologies.
Okay, great. So I'm just going to ask everyone to kind of look into their crystal balls, which I think you've got under the desks if you check. And if we could just sort of have where do we think this might go in the future? I mean, I'll sort of start us. I mean, are we looking at in the future that the idea is that you have lots of autonomous machines on site that can all kind of talk to each other? Would that be something that would be feasible in the next X number of years? So yeah, I mean, this is a question for all of you. Just kind of where do you think this might kind of feasibly go in the next few years, or where might you hope it might go?
I'll start for the day. I'll start for the day today. Where we are today is we still have 36,000 excavators sold a year in Europe, yet only 8% of them have any sort of automation on them, or any sort of any sort of machine control technology. So we're still quite a way off. Yeah. And if you think of all those machines live in the market for 3 to 5 years, there's a lot of machines out there with nothing on them still. So we're still a way off, even in basic machine control technology. It's growing fast. But I think as everyone talks about BIM, and BIM is basically the ability to know where everything is and where it's been put. So it's electronic workflow for the construction industry that is becoming mandatory across Europe. So machine control will become mandatory. And the first part will be whether we use machine control as a sensor on site. It records everything it does, where everything is and where everything's been put. And that's the first part of the technology. And we're, in some countries, it's compulsory. In other countries, it's going to become compulsory. The biggest construction project in Europe for the next number of years will be HS2 in the UK. And the technology is mandatory on that whole project. You have to have the ability to know where every single cubic meter of soil came from and went to. So every truck will be tracked, every single bucket of soil that's lifted into a truck will be tracked and traced, all the material that comes. So in 10 years' time, you know, on that point on the ground, that material came from this place. And that's the start of our business. Full automation and autonomy, I think will come in certain industries. Mining is easy. We see it more. I see it more and more on our agricultural side of our business because it's easier, because it's the same place every year, the same obstacles, the same task daily every year. So it's quite a repetitive task. I think automation will come initially for the repetitive tasks. A trench is a trench is a trench. If it's 100 meters long by 2 meters deep and it's a continual fall, it's a pretty repetitive task. So these are sort of tasks that automation will definitely step into. And with the way the computing power is going and the speed of connectivity, the machine will only stop when it sees something it's never seen before. It runs back to the operator and says, "I've met something I don't like." It'll come. But that's not in the short term. I think the construction industry is very conservative still. We've dragged them screaming this far, but they're starting to see now the benefits. But it's still a little while off. As a manufacturer, we're working. The OEMs are driving the business now. They're starting to put this automation is now coming from the factory more and more. And as a supplier now, we're supplying more of the data services around the machines. So we're able to send data back and forth. We can record productivity, tasks are set for the machine. So we're seeing ourselves as a manufacturer of machine control. Yes, we're working with the OEMs, but we're becoming more of a data partner for them. But it's going to take a while. The construction industry is extremely conservative compared to other industries, especially manufacturing industries. So much as I'd love to say next 2 or 3 years will be 100% automated, I think it's going to be tough.
Yeah, picking up on what John said, yeah, this theme of the conservative industry says to me that the mainstream evolution is a buildup of more and more operator assist functions. I used to say that, you know, you want to make the technology so sophisticated that you can't tell it's there. So it's more natural. And it's just a little bit more help and a little bit more help and a little bit more help, and the job gets easier on the operators. And I think this is how the mainstream builds up. But at the same time, I think the push for productivity from the big fixed sites, the mines and the quarries mostly, we'll start to see actually much more push towards higher levels of autonomy, closer to full autonomy. So I think you'll see that coming from one end and this slower build up from the other end. Eventually they converge, but that convergence point is far in the future.
Mm-hmm.
Yeah, I think to your original question, Andy, you know, we're already seeing machines talking to each other on our job sites. And what we think is going to be really important is that, going back to the interoperability question, it's going to be incredibly important for machines of regardless of make to be able to talk to one another. And so I think that's one of the reasons we've pursued our aftermarket approach, is that there needs to be sort of a unifying software layer that talks across all different types of equipment. So today, what we do, it's an aftermarket upgrade, but we think long-term, we want to partner up with the OEMs. We want, you know, the hardware to be baked in at the factory level. And then, you know, we view ourselves as being sort of this third-party software that can kind of interact with all different types of machines. But we are seeing, single operator able to run multiple machines that are of different makes already today. I think as far as adoption is concerned, it is still very much early days, as everyone has said. I think one of the unique things about construction, though, that will really drive adoption is that it is in a very operationally intensive industry. The competitive dynamics are very intense. And so to the extent that there are one or two early adopters who start to reap the benefits of automation and are able to become meaningfully more competitive, they're able to bid their jobs more competitively, you'll start to see a big group that wants to follow and wants to also start to take part in this. And so I think once we hit a certain critical mass, the adoption rate will really start to move swiftly. Now, is that 1 year or 5 years? I would say, it's going to be more than 1 or 2 years. But I think the wheels are already in motion, and I think that the rate, like in 5 years, construction will look fairly different.
Mm-hmm. It's interesting, isn't it, that we talk about it kind of being early days for this, but then it's something that's been around for 20 years or 25 years, as as you guys were talking about at the start. I'm just going to go, because we've had so many good questions from people watching this, and again, thank you very much. I'm just going to quickly try to cover one or two more before we have to end it and let everyone get on with the rest of their days. So we've got one here which might be interesting to cover quickly, which is just looking at, so it's from Philip Herman, and it says, how will machine autonomy impact the size, capacity and design of construction machines in the future? Does anyone want to jump in on that? Alan, do you want to jump in on that?
Yeah, I was just thinking about that because there's a lot of ways you can go with that. But I think you do see some opportunity there if it's autonomous and maybe converged with electrically operated, that you don't have so much negatives from having more smaller units. So some places, if you move towards think about production systems that work more in continuous flow, that trend is always towards smaller discrete units becomes more continuous. So I think actually there's a potential for more smaller machines, but it depends on the application. Sometimes you just need the mass to do the job, but I think you would see groupings of smaller autonomous machines are enabled by this.
I think that's exactly right. And I would add to that, I also think there might be a move away from more specialty equipment as well, where today the benefits of using specialty equipment is that it's suited for a particular task. It's far more efficient for on a single unit basis. But if you now don't, let's use a trencher as an example. A trencher is probably 3 times as efficient as an excavator. But now if you can have 3 autonomous excavators with no additional labor cost involved, well, you might prefer to use 3 excavators because you can use them for different tasks on your job site as well. Or, when a trencher goes down, it's hard to come up with a replacement unit as easily as with an excavator. You might have another one that you can just swap out fairly easily. So I think for that reason, you might see a slight move away from more specialty equipment and using more general equipment across your projects.
Mm-hmm. Okay, and I understand that, as John said, in terms of the adoption rate it needs to increase at the moment. I think you said 8%, didn't you, John, of the excavators sold in Europe. But if I kind of may, if you may indulge me and I kind of leap ahead, in terms of obviously at the moment we're saying that automated equipment needs to be certain repetitive tasks. Is that going to be, because obviously telematics, as the amount of data that we have now is crazy compared to what there was a couple of years ago, and obviously that feeds into AI. Is this then that we think that maybe in 5 years time or 10 years time maybe the intelligence will be there to not just do these repetitive tasks?
It's a good question. I don't. It's again, there's still a level of input needed, because every time you dig a hole in the ground, you have no idea sometimes what you're going to find. As the machines get clever and as AI gets clever, you only have to teach it once and it's learned. So that's for sure. But it's the construction industry is so diverse. We do so many different things every day on site, and every site is a little bit different.
Yeah.
So it's still a very unique business. It's so yeah, it's a tough call. I think we'll see a lot more. As Gaurav says, you'll see one good operator on a site operating 5 or 6 or 7 or 8 or 9 machines, and the operator will be sitting next to the engineer, which is where he should be, and they'll be discussing the project and productivity and all these other things, and the machine is doing what it should be doing. It's just working. That is definitely the next step in the business.
But I think these smaller job sites, where it's a lot more one-off things, the overhead of trying to put a plan in place that the automated machine can follow, it is going to be a challenge for quite some time. If you're a small contractor, you've got to do the utility trench from the house to the curb to put in the utilities. It may, this is maybe a 20-30 minute job for a decent operator. It's probably faster just to jump on the machine and get it done.
Yeah.
Yeah, I think that's right. And I think technology it moves incredibly slow until it doesn't, right? And I think people, we got a little ahead of ourselves on autonomous passenger vehicles, right? Cars. Everyone thought, okay, 2020, we're going to have self-driving cars everywhere. And I really don't think that that's going to be the case for another, at least 10 years. But I think the benefits of construction is that construction as a space is very diverse, and there are lots of different types of job sites, and some are more systematic than others. And so I think in terms of moving forward, you will see early use of automation in the next 3 to 5 years. I think for, full penetration that, everything is automated, that won't happen for quite some time. But when it does, it'll be really big. And I think when you think of the type of technology we're talking about is really considered frontier tech, right? It's the type of SpaceX innovation. It's not, it's not Salesforce or Facebook. It's not built overnight. It takes many, many years and a lot of feedback from the field where you've deployed the robots, you see kind of how they behave, and then you iterate on them. However, what's different about this compared to kind of traditional mechanical innovation is that when an upgrade or an improvement is made, it's made to the software. And just like you're starting to see with Tesla or other kind of vehicles, it's a software upgrade that can be deployed across the fleet. And so an improvement made to one excavator will be made to thousands of excavators. So I think for those reasons, the improvements will be rapid when they do occur, but it will take some time to get there. I think we lost Andy.
Seems like you froze.
Sorry, I think my Wi-Fi cut down. That's good. I was thinking we've been so good throughout the whole thing, and then right at the end, that would have been terrible if I just cut off. So I'm back just in time to say sorry that we cut you off, Gaurav, but I'm happy that I'm back to be able to say, Alan, yeah, so we said we we're going to be 45 minutes and we've overran by 15. Thank you very much to all the questions that came in, and I can see that the attendees have remained pretty strong throughout this time, which is why I wanted to carry on going, because obviously people are interested in what you guys are saying. So Alan, thank you very much for your time. I really enjoyed it.
Thank you.
John, thank you very much.
Thank you very much. It was fun.
Great. Gaurav, thank you very much.
Yeah, it's a lot of fun. Thank you.
Great, thank you. And now I will just go with me for a second. And so yes, thank you very much for watching. This recording will go live onto the website in a couple of days' time with this weird kind of gap at the end, but you obviously know what's happened. It just remains for me to say thank you to our sponsors, who are Smart Construction, Volvo Construction Equipment, and Inspire, and to thank you once again for your time and for viewing this. Thank you very much. Goodbye.